Selection is a fundamental task in interactive applications. One way to model selections is as declarative queries over interface objects. Here we see world development statistics for the year 2000. The x-axis shows per capita income, and the y-axis shows internet usage as a percentage of population. Circle size is proportional to the country's total population, and color corresponds to geographic region. Our system translates selection gestures into declarative queries. Clicking items selects them directly. Drag operations on the visualization and axes generate range queries. And clicking on the legend selects all items with matching attributes. Selection criteria persist over transformations and updates to the data. Here we transition to a log scale, and then animate the time series from 2001 forward. The selected items update dynamically. This visualization shows homicides reported in Los Angeles in 2007. Color indicates the cause of death and shape indicates the victim's race. We select all the gunshot victims in central LA. As with basic brushing and linking, the selection persists as we transition to different views of the data. Here, a stacked bar chart shows homicide counts for each month. Next, a scatter plot shows incident date and victims' ages. At each transition, the selection query is retargeted to the new view. Because our system maintains the query structure, it can automatically create new dynamic query widgets for conveying and refining the selection criteria. Our system can also use the structure of an initial selection query to generate expanded selections. Clicking and holding a selection pops up a dialog box. We can use relaxation to expand the selection along any dimension in our dataset. This lets us quickly select other victims with the same age, race, or cause of death. Here we select a range rather than a single item. This lets us select all items that have the same cause of death as the items in the range. Similarly, we apply relaxation to time series data to select all time series that pass through a range. Sometimes, data dimensions have semantic structure that can guide the relaxation process. Hierarchies are a common structure. For example, we can organize time into days, weeks, months, and years. Here, repeatedly clicking expands the selection to the day, the week, and then the month in which a homicide occurred. We also apply our selection techniques in a vector graphics editor. Again, users can select individual items and ranges. We can relax selections based on properties such as shape and fill color. In this example, visual items are connected in a network. Such networks are another form of semantic structure amenable to relaxation. Here, multiple clicks cycle through an item, then its immediate neighborhood, and finally its connected component. In conclusion, our system models selections as declarative queries over interface objects. Users create and refine selection queries through direct manipulation. By maintaining the query structure, our selection techniques support dynamic data and can be reused across interface views. Query relaxation techniques manipulate these selection queries, forming generalized selections from simpler initial ones.